So section 4.4 is going to discuss Herons formula. Herons formula has been around since, I don't know, last 2,000 years just about, and maybe even older, we're not sure. But it's for finding the area of a triangle if you just have the length of the sides. Now, it's pretty cool because it doesn't require us to know anything about the angles. It's just all about the sides. The first thing you need to do is calculate what is called the semi-perimeter. So basically the perimeter, peri meaning around, meter meaning distance. If you divide that by 2, you get the semi-perimeter. And what we're going to do is we're going to take that semi-perimeter, take this square root of this product. It's going to be S times S minus A times S minus B times S minus C. Pretty brilliant of somebody to figure this one out, to be honest. It's not that hard to use. There is a little trick that can make your life a little bit easier as we use this. So let's do an example of this. I think I wanted to do problem number 27 from your handout. So that'd be this one. We got sides of A equals 11, B equals 14, C equals 20. So let's work with that. Number 27, A is 11, B is 14, and C is 20.
Do we also have to find out the angles as well for all these triangles too?
I guess it depends on what's asked, but if you're just asked for the area, then the simple answer is no. You don't have to worry about the angles at all. Now, if you do have some information about the angles, that can make your life a little bit easier. It depends on the particular problem, and I'll get to that in just a minute. We'll start by calculating the semi-perimeter. That's going to be 11 plus 14 plus 20 all over 2. So, if you want to add that up in your head or if you want to do it in your calculator, either way, it's going to be 45 over 2. But here's my suggestion. When we do this, we're going to do it on our calculator. So let me clear out a little of the stuff here. I'm going to start by taking that 45 divided by 2. Don't hit the enter key yet. Take 45 divided by 2 and hit the store key. The store key is on the lower left-hand side. We're going to store that in X. So that's really taking the place of S in our formulas over here. We're just conveniently storing it in X because it's going to be easy to access that way. And now, one at a time, we got to take X times X minus A, X minus B, X minus C, that product, but that's going to be pretty easy. So let's see, we want the square root to start off with, square root, and then it's going to be X, and then parentheses, X minus A. Well, what was A? We don't have that stored, so we have to actually type it in. What was A? 11. So X minus 11, and then X minus 14, and finally X minus 20, and bam, there you are. An area of 74.15. They didn't give us any units here, so we'll just go with, I'll just write square units because they don't have any units here. Typically speaking, when you're talking about area, it's going to be in square units. If you start out with inches, it'll be square inches, yards, square yards, etc. Square units. So pretty nice. Pretty nice. Very convenient formula to have. We're okay with that first example. Because I'm going to make it a little bit more challenging here. We're going to work with the wing of the European Typhoon fighter. So let's switch over to that next one. And I think that's down here a little ways, right here. So Typhoon has a canard delta wing design. Basically, it means you've got this triangle of a shape coming off of the wing or off of the main fuselage of the plane. And let's zoom in on that a little bit. Right here. So we've got 3 sides here. Perfect. That's all we need. If all you're asking is trying to figure out what's the area of this, then you've got the 3 sides. So let's work on that one. So I'll call this example 2, for instance. And we've got sides of A is 4.55. B is 8.05. And C is 8.75. We should also note that this is in meters, so your answer should be in square meters when they're all done. Now to start out with, you want to calculate the semi-perimeter. And I guess it's going to be up to you a little bit as to how you want to do that. I think the easiest way is just to make sure you use parentheses and then type in 4.55 plus 8.05 plus 8.75, close parenthesis, and then divide by 2. But before you hit the enter key, what else do you think I might suggest you do?
Store it.
Store it, absolutely. Let's store it. I mean, it's going to be some ugly number. I'm not going to want to type that in repeatedly into my calculator, so let's just store it. Then put it into Herons formula. Calculator. Oh. So it's going to look like this. Actually, you know what? I can cheat. I want to see a little bit of a cheat here. If you hit the second key, then the enter key, it'll bring up your previous calculation. If I do that one more time, you know what? I guess I can't cheat because these numbers have changed. Yeah, never mind. All right, but 4.55 parentheses x minus 8.05 parentheses. You don't need to hit the times between the parentheses. It understands that that's there. And then x minus 8.75. Close parenthesis. So, wow. All right. Is that what you're getting?
Yeah.
Getting the same thing? All right, good. So, this one, the area is about 8.177. 8.177.
18.
Oh, 18, I'm sorry. Thank you. 18.177. But if I saw 18.177 for a problem like this on an exam, I think I'd be a little unhappy. What else am I looking for, Mitchell? What else would I be looking for in this as part of this answer?
Units.
Units. Yeah, units. So the units in this one would be what?
Meters squared.
Meters squared. Excellent. So, beautiful. Now, it's doubtful that I'll give you one like this, but there is kind of a nice special case of all this, and that is if you have a triangle in which all three sides are the same. So, A, B, and C, maybe they're all length 4. Does anyone know what such a triangle is called?
Equilateral.
Equilateral. Equilateral, meaning equal sides. Now the area for this special triangle, this is not a formula that I require you to know. Area is going to be square root of 3 over 4 times s squared, where s is the length of one side. So it's a special formula for the area of this triangle where all three sides are length s. By the way, if all three sides are length s, what does the law of sines tell us has to be true about the angles here?
60.
They're all the same. They're all 60. So nice. Anyways, not one that you should necessarily expect, but yeah, still a good one. Let's change things up a little bit. And suppose I gave you a problem like this. I said, all right, here's your triangle. You have A with an unknown side, B of length 4, and C of length 1. But I'll tell you that A has angle A has a measure of 120. One of your possibilities will be to use the law of cosines to come up with that missing side, right? And then when you have that missing side, then you could use Heron's formula and finish it up. Let me suggest a better way, and it's kind of cute if you want to think about this problem for just a minute. We can figure out a better way. In fact, let me just get a whole new sheet of paper here, and then we'll come back to this. Suppose you wanted to find the area of a triangle, but maybe you don't have all three sides. Maybe you have two of them. So let's take a look here. And again, I'm not trying to draw any particular triangle. So B. Does anyone remember in general the formula for an area of a triangle?
That's base times height.
1/2 base times height. So the area is 1/2 the base times the height. The height is taken as the length of this side if you go perpendicular to the base. Okay, so that's the base. I'm going to conveniently throw in that side right here. That's an H. So, okay. And if I were to solve for H in this scheme here, can anyone think of trigonometric formula that involves this angle, this side, and this side? Sine. Well done. Sine of theta is opposite over hypotenuse, so it's going to be H over A. How would I solve for H? What do you think I could do to solve for H? Maybe multiply both sides by A. A sine of theta equals H. And that's kind of interesting because that gives me a formula that I can plug in right there. And if I plug that in, I get 1/2 B times A times sine of theta. Or better yet, I can rearrange this as 1/2 AB sine of theta. Wow. So that's kind of nice. What it's saying is that if you have an angle between the length of two unknowns or two known sides, you can find the area. That's cool. That's worth remembering. There's lots of different versions of this formula, but it works out to be the same. You have two known sides separated by a known angle. You can find the area. Take a look at how easy it makes the previous problem. This one. I don't need to go ahead and solve for theta or solve for A here. Yeah, go ahead.
So that area formula, is that only for like triangles or any triangle?
It's a great question. It's for any triangle. It doesn't have to be a right triangle at all. Now if it's a right triangle, that's fine, then it'll end up, you know, I guess it depends on where you're taking theta, but if it's a right triangle, that's fine, it'll still work. Good question, thank you. Cameron. Yeah, thank you, Cameron. All right, so let's see. Here it would work out to 1/2 4 times 1 times sine of 120. Now I'm not really concerned about getting an exact value for a problem like this. We do happen to know what the sine of 120 is, at least I hope we do. Someone shout it out. Sine of 120, come on, make me look good, we're on national television. All right,
With 302?
yeah, there we go, thank you. All right, I might have been exaggerating a little bit when I said national television. Half of 4 is 2, and then this is going to be square root of 3 over 2. So overall, I'll end up with the square root of 3 here. Great. Just a quick FYI, if you actually did have all the rest of the information, you could solve it with Heron's formula, and you would get the square root of 3, which is about 1.732. You want to see that? You want to see that it works out? See it works out the same way? All right. Let's see, quick fact, with this setup here, this side would have the length of the square root of 21. But let's try it with Herons formula and see what we get. So let's clear out a bunch of stuff here. Clear that out. And I'll start out with parentheses. You know what, I'm gonna, instead of just doing parentheses and then divide by 2, I'm gonna show you or remind you of another little trick that you can use. If you hit the alpha key, then the y equals key, this first option here gives you a numerator and denominator. You can just do a regular old fraction. So doing it that way, I'll do square root of 21, exit the square root, plus 4 plus 1, divided by 2. I'm still going to store that value in x. It's going to be some ugly looking value. Let's do Heron's formula then. It's going to be the square root of x times x minus 1 times x minus 4 and then x minus the square root of 21. And let's see, exit both square roots. Let's see what we get.
Oh,
Are you sure? What if I squared that? Oh, if I square that, I get 3. Nailed it. Nailed it. So pretty nice.
How did you get the fraction at the beginning?
So one more time for that fraction at the beginning, you're gonna get the alpha key, then the y equals key, and then enter. So you can see it in my key history right here, alpha, and y equals, and then enter. Okay, so down below. Comments on that one? Yeah.
This one, did you get the square root of 3 for the first one and then 3 for the second one, or did I miss the first part?
Yeah, the area was square root of 3 for the first one, yes, and the second one. What I did with the second one, because I wanted to convince myself that this answer really was the square root of 3, is I squared it, and because when I squared it I got 3, then I must have started out with the square root of 3, so that was my logic in that one.
Okay.
All right, awesome. Let's do one last example like that. Let's see. Let's look at our handout. Now they got a couple other formulas in here that I just have never used, and I'm not going to require them. There's these down here. You know, we're just going to stick with the formulas that we have. So let's try problem number 21. Bless you.
Thank you.
Bless you squared.
Oh, hey.
Boom, boom. All right. So A is 3, C is 2, B is 115. So this is perfect for Jeff's formula. We don't have to use Heron's formula. In fact, I would hope that you wouldn't use Heron's formula for a problem like this. So, example number 21. This is set up perfect to use that formula we derived. Here is going to be 1/2. And then just fill in all the good stuff. Hey, what do I fill this in with?
Fill it in with 3,
Mm-hmm.
2, and well,
Yeah, 115.
okay, yeah, that's
Yeah. So perfect. Now 1/2 times 2 is going to cancel, so it's just going to be 3 times the sine of 115. Probably the easiest place to go awry in this formula, in using this formula, is where? Where do you think the easiest place to make a mistake is?
Friend, it's taking this time.
Having the wrong mode.
Uh,
If you're in degree mode, when you're supposed to be in radian mode or vice versa, that'll mess you up. But this just turns out to be 3 times the sine of 115. So, wow, 2.7189, etc. Yay.
What?
Julian, you getting something different?
Oh no, I didn't know what.
Oh, I just copied down the answer.
Oh, okay.
So, nice. Oh, probably one thing I should write here. At least I like to see it. Units squared. Or square units, whatever you want to write. Beautiful. Beautiful. Are you feeling okay with finding areas? Is this going to be like, oh yeah, you'd be happy to see these problems on the next exam? All right, good. If you have some questions or something like that, please reach out and get some help. More than happy to help you out. Plenty of office hours, so do reach out.